so this exercise here tells us to write an equation for a circle centered at 4, -2 with a radius of 6. So the center here, this is like our HK. So 4, -2, h is 4 and k is -2, and our radius r is equal to 6. So we're just going to plug that into our formula. R squared is equal to x minus h squared plus y minus k squared. So we have 6 squared is equal to x minus a 4 quantity squared plus y minus a minus 2 quantity squared. So these ones change to positive, and we can just finally write our equation for the circle is 36 is equal to x minus 4 quantity squared plus a y plus 2 quantity squared. Okay? And it's as simple as that. So now let's go back and look at a circle. Okay? So let's say we have a circle like this, alrighty? And it's somewhere in our xy plane, like that. Okay, so here's our center, here's our radius, and all of that good stuff. Okay, so we have a circle like this, let's say. And let's try to do the vertical line test. Remember what the vertical line test tells us is that if a graph or a function passes the vertical line test, then we have a function. And we see that this circle actually crosses in 2 points at multiple x values, right? So this is kind of surprising, right? Because the circle fails vertical line test. So what does that tell us? That means that a circle must not be a function. That's really weird, because circles are really useful, aren't they? But so we could say this is not a function, as we have defined a function. For every one x value, or for every input, you only get one output. So this means we can't explicitly solve. So we could say, so we can't get y as a function of x only, and we can't get the other way either. And we can't get x as a function of y. Okay, so that means that whenever we do try to solve for points on a circle, we have to solve it algebraically. Alright, so let's see an example of what I was trying to say on the last slide. So it says find the points on a circle of radius 5 centered at the origin with an x value of 3. So here it says, okay, so we have a radius of 5, so that's good. We can say r is equal to 5. And origin just means the point 0, 0. So h is 0, k is 0. So we can write our a general equation for our circle, right? So we have r squared is equal to x minus h squared plus y minus k squared, right? And then if we just plug in our values here that we know, we get 5 squared is equal to x minus 0 squared plus y minus 0 squared. Okay, and then we just simplify and say, okay, so 25 is equal to x squared plus y squared. All right? And then the question is asking, find the points on this circle, with an x value of 3. So that means we're going to fix our x value at 3 and then just solve for y. So now we can just plug in 3 for our x value, so we get 25 is equal to 3 squared plus y squared, and now we're just going to solve for y. So this is the same thing as saying 25 is equal to 9 plus y squared. So if we subtract, we just get 16 is equal to y squared, so then y is equal to plus and minus 4, okay? So we actually get 2 points out of this. When our x value is 3, we could get the point 3, 4, and we can get the point 3, -4, right? And here's why. I'll just show you graphically. These are our answers, the points on our circle. And graphically, this looks like the following. So let's say we have, we're centered at the origin, right? Let's say here's 5, 5, 5, and 5. Okay? So everything, we have a circle centered at the origin with a radius of 5. I'm just going to pretend that went through the point 5. Okay, so here's x and y. And we said, okay, so at the x value of 3, let's say it's there, we have 2 points on our circle. Right here at 3, -4, and one right here at 3, +4. Okay? So that's all it means, is we just found those points on the circle with an x value of 3. Alrighty, so here's the last example for this concepts video. It asks us to find where the line f of x is equal to 4x intersects this circle here. X minus 2 squared plus y squared is equal to 16. Okay, so it's like, what? Hold on. How do you find where a line intersects a circle? So the thing is that we can rewrite this one as y is equal to 4x, okay? And what we can do now is, what we really want to happen is that we're searching for an intersection between these two curves, okay? And yes, a line is a curve, even though it's straight. It's just a straight curve. Anyways, so what we want to find, so the intersection between two curves, is the same as saying, we want to find the xy points where, or well, we could say xy points that satisfy both equations at the same time, right? Both equations at the same time, right? That's because this is just saying, let's say you have a circle, right, and some line, okay? So in order to find this intersection here and this one there, that just means you have an xy point and another xy point which lie on both the circle and the line at the same time, right? That's simply all it's saying. So what we can do now that we have this equation of the line, y equals to 4x, and the equation of our circle, which was given, now all we have to do is just find out x and y, which it seems easy, and it is. Because now, what we can do is plug in this 4x into the y spot here, okay? Because we're assuming that the y's are going to be the same at some point. Alrighty, and then we're going to try to find the x value at that point, and then go back and actually find the y. Okay, so let's just plug this in and see what we get. So we have x minus 2 squared plus, and now in for the y spot, I'm going to write parentheses around it, we're going to plug in a 4x, okay, is equal to 16. So let's continue this on the next slide. So we have x minus 2 quantity squared plus 4x squared is equal to 16. Okay, and then if we just kind of FOIL things out, this is the same thing as saying x minus 2 times x minus 2 plus a 16x squared is equal to 16. Okay, so this gives us x squared minus a 4x plus 4 plus 16x squared is equal to 16. If we just move everything to the left-hand side and combine some things, we get 17x squared minus 4x, and then if we subtract that 16 over, we'll get a negative 12, okay? So is equal to 0. Alrighty, so here, this doesn't look super factorable, so I'm just going to plug it into the quadratic equation and see what we get. So x is equal to negative 4 plus or minus, and then that squared, so that would be a 16, alrighty? And then minus 4 times a times c, and then all over 2 times whatever a is, okay? And this simplifies, simplifies, to 4 plus or minus the square root of 832, pretty big numbers here, over 34, okay? So x is equal to, or about equal to, 0.966, or negative 0.731, when you plug that into your calculator, okay? So these are the two x values where our intersections lie. Okay, and now what we're going to do is just plug it into either of the original equations to solve for the corresponding y values, okay? So let's do that on the next slide. So we have x values of something about 0.966 and an x value of negative 0.731. So we're going to pick from this equation here, y equals to 4x, or this equation here, plus y squared is equal to 16. We can pick either one of these equations to plug in our x and then figure out the corresponding y. And personally, I would choose this one, just because, makes life easier. So let's pick this one. So we have y is equal to 4 times, let's pick this first value here, 0.966. And when we plug that in and plug it into our calculator as well, or you can multiply if you like doing longhand multiplication, 3.864, okay? So that means that one of the points of intersection is 0.966, that's the x coordinate, right? And we found our y coordinate to be 3.864. So this is one point of intersection, okay? Now let's solve for the other point of intersection by again plugging in this x value that we found already. 4 times negative 0.731. This gives us a negative 2.923. Okay, so this is also another point of intersection between the line that we were given and the circle. Okay, so this is going to be negative 0.731. comma, negative 2.923. Okay, so that is another point of intersection. Alrighty, so that wraps up our concepts video on this section on circles. I hope that helps, and I'll talk to you in the practice problems video if you want.